All right, we are going to be reducing radicals with higher order indexes. Hopefully you can hear me. I'm doing this on a whiteboard, so in my house, so things happen. So let's see what happens. Okay. So when you reduce radicals, the basic procedure is to create two radicals. Whatever the indexes are, this side is anything perfect. Perfect squares, perfect cubes, perfect fourth roots, anything like that. And here is what's left over. This one stays left over, and then this one right here, you take the root of. So that's the idea. That's what we're going to do. And I picked two problems that we'll work through that have cubed root and fourth root. Okay. First one is cubed root. I have a wall right here. This is why I'm all squished. Okay. The cubed root of 32 x to the 5th y to the 8th z squared. Now, first thing you have to ask yourself, what is the root that I'm looking for? So here, this is it. We're looking for perfect cubes. So I like, on the side, maybe list out some perfect cubes. So my perfect cube numbers are 2 times 2 times 2, which is 8. 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. Now 64 is too high. It's not 32. Check, does 27 go into 32? No. But 8 goes into 32. So that's good. So we break it up into two houses. The good house, the bad house, the perfect square is what's left over. So 8 is our perfect square that goes into 32. So that's perfect. It goes here. Okay, 8 times what is 32? 8 times 4. 8 times 4 is 32. That works. The next thing that we need to do is look at our variables. Now with variables, hopefully you remember, the exponent has to be divisible by this number. So all of the exponents that you could have are multiples of 3. So the possible exponents are, here, let me erase this, the numbers. The possible exponents are x to the 3rd, x to the 6th, x to the 9th, x to the 12th. Now, we don't have anything higher than that, so these are our only possibilities. So, x to the 5th is the first one we're looking at. This is the only one that could possibly work with that. So x to the 3rd goes here. Now x to the 3rd times what is x to the 5th? X squared. Because 3 plus 2 is 5. So we do the same thing with the y. So y to the 8th, the closest we could do would be y to the 6th. So we do y to the 6th times y squared, and that's it. Z squared, is there anything less than z squared that makes a perfect square, a perfect cube, excuse me? No. So z have to stay over here. Okay? Most of the time we get up to this far, but then we have to take the root. This doesn't change. You can't do anything with that. No matter how much we want to, we can't do anything with that. But then this, we have to take the cubed root of. Now you can use your calculator and find the cubed root of 8, but you can remember over here, we did 2 times 2 times 2 was 8. So the root is 2. Okay? Now x to the 3rd, that's x times x times x. So, or you simply divide this 3 by this 3. 3 divided by 3 is 1, so it's x to the 1st power or just x. Y to the 6th, take the 6 divided by 3, and it's simply y squared. So that is simplifying a radical. There's nothing else you can do. It looks nasty, but that's all we got. Okay, so we'll try it with a fourth root. Maybe I'll use colors. It'll be all good. Or maybe I won't even use this because I'm fat. Whatever. All right, so let's do the fourth root. The fourth root of 64, x to the 5th, y to the 6th, z to the 10th. So the same process we need to follow. We need to find the perfect fourth root and leftovers. So the perfect ones, we have to figure out. You may know them right now, but maybe not. So we start with 2. Now this time it's 4. 2 times 2 times 2 times 2. So it's 8, so that's 16. Okay, what about 3 times 3 times 3 times 3? That is 81. Okay, that's too big. So the only one that we can use is 16. So 16 goes into 64 4 times. So 64 does not go there. Thank you very much. 16 goes here. 16 times 4 is 64. So then here, all of the exponents have to be multiples of this 4. That's the key here. Multiples of 4. So the exponents I could use are x to the 4th, or y, it doesn't matter the letter, x to the 4th, x to the 8th, x to the 12th, x to the 16th, and so on. So we look at it, x to the 5th. The only one that could be inside of x to the 5th would be x to the 4th. So put x to the 4th here. X to the 4th times x to the 1st is x to the 5th. Y to the 6th, the only one less than y to the 6th would be y to the 4th. So it would be y squared here, because 2 plus 4 is 6. And z to the 10th, well, z to the 10th, we get an 8th power. So we'll do z to the 8th and z squared. So now, that's wonderful. Don't confuse this. This is a fourth root here. Okay, now this one stays the same. We can't change this one. You can't take the roots. We've already decided these are the leftovers. They stay where they are. This one, now we have to take the square root, or the fourth root. So the fourth root of 16 is 2. You need 4 to take 1 out. So the square root of 16 is 2. That goes there. And to find the square root, or the fourth root, to find the fourth root of these, you just divide them by 2. I mean, shut up! Divide them by 4. 4 divided by 4 is just 1. 4 divided by 4 is 1, and 8 divided by 4 is 2. Just came home from school. I'm getting this done for you. Here we go. And that's it. It looks messy, and it's a horrible mess, but if you can do this, you can do anything. Oh, almost anything. Maybe you can't fly. Okay? So do your best. Hopefully you like it, and I'm not too huge.